Hey guys, my name is Arab Jaiswal and welcome back to another video of the periodic table of elements part 1, which is why we use the periodic table. So part 1, which is why we use the periodic table. Well, first we need to understand what is the periodic table exactly. So the periodic table is contained of a group of elements, and those groups of elements are classified into three main categories, which are metals, metalloids, and nonmetals. So let's start off with the basics and jump into why we use the periodic table. And so we use the periodic table if you're a chemist. So if you're a chemist or a person who studies chemistry, or you're working in the lab and like to figure out different types of reactions and stuff, then you would definitely need to know what the periodic table of elements are. And if you guys didn't know, there are 118 elements in the periodic table of elements. Now, you might be wondering, why is the periodic table in a tabular form? Why isn't it not on a in like a column wise, that where we can just write it on a sheet and boom, there's all the elements? Well, there are five main reasons, or reasons why it's in a tabular form. The first and foremost reason is that it gives more information provided as it is to column, as it is if you're to just write on the paper, because as you can see in the periodic table of elements, each element, they show its symbol, its atomic number, what it's classified into based on the color, and it gives like a lot more information than as you would on just like a piece of paper for just one particular element. And if you're going to write the information, then you're going to need like at least two or three sentences. And if you just use it in a tabular form, it's going to be more efficient. You just have to look at the key or the legend, and that will show what the attributes of it are. So that's the main behind the concept idea. Now, our second reason is that we this can help us find how reactive it is. So like, let's say that you are using the reactivity scale, then if you find out what its electronic configuration is, then you'll be able to find out how reactive it is. So meaning that if the outermost part of the electrons, if those are, let's say, symbolized as 1 in the first column of, or the first group of periodic tables, they have the atomic electronic configuration of the outermost electron as 1. So 1 is going to be definitely more reactive than it will be if you have an outermost electron for 2, meaning that there will be two outer electrons that are going to be needed to do the reactivity skills. And because there's two, it's going to be taking like a longer time. But if there's just one, it's going to take a shorter amount of time, and it's going to react more than it is for like a 2 or 3 or 4 or any of those. How? So those are some reasons why we use the periodic table. Now we're going to find out how these elements came on to the periodic table, meaning that how are these elements founded? How did we find the atomic number? So in order to found the atomic number, we use the cathode ray tube. Well, mainly J.J. Thomson used the cathode ray tube. So he wanted to know that back in the olden days, people would always find like metals and metalloids and these gases, and he wanted to do it in like a periodic form, and people would always get like confused, like, okay, is this like a metalloid, is this the gas? So to sort it out, what J.J. Thomson did is that he created a cathode ray tube, and that cathode ray tube is showing that how what the atomic number is. So what he did was that it's mainly the vacuum that he put. There's nothing inside of it except for like two bars, two metal bars. One is the cathode ray and one is the anode ray. The cathode ray, that shows the positive, the anode shows the negative. And so he would see that once he would enter that element, so he would look for any elements that were there in particular. So he took hydrogen and he put that into his cathode ray tube, and he saw that only one electron went to the anode side and one proton went to the cathode side, meaning that only one, the atomic number was 1 for hydrogen. Then he did the same thing for helium. He found out that there were two electrons and two protons that have been passed through. And he found out that helium's atomic number must be 2. And then he did this for helium and for lithium, beryllium, boron, and more elements. And as scientists gradually started to know more about these elements, they put it in the cathode ray tube, and based on how many protons and electrons are what is shown in the atomic number. And that's how the atomic number is created. It's not just to show that there's just hydrogen is 1, helium is 2. No, it's not like that. It's not that J.J. Thomson or whoever just randomly put the elements as their atomic number as 1. There was a specific idea to why hydrogen was the first idea, meaning that it was the first one that had one proton and one electron that was passed through it, meaning the atomic number was 1. So that's why that's that's how the atomic number is found. So now that we found out the atomic number, now we're going to look at the metals, metalloids, and non-metals. Now you can also check that out on my next video. I'll be showing the difference and types of attributes of metals, metalloids, and non-metals. And you can check that video out to understand. But just to give you like a quick recap, metals are the hard items which that we can see, like gold, copper, silver, and mainly 70% of the periodic table consists of that metals. Then we have the non-metals, which are like the gaseous metals, meaning that there's like hydrogen, nitrogen, helium, oxygen, carbon. All those are non-metals. And then metalloids are going to be attributes of both, like mercury or any type of liquid. Like mercury, that's a good example of a metalloid because it has like a few attributes of metals and a few attributes of non-metals, making it metalloids. So that's just a quick recap. Now, in order to find it, there will be a key. Like I said earlier, there is always going to be a key in the periodic table of elements, and the color doesn't show that people didn't just color it based on what they wanted to, just for fun. Like, oh, it was just a coloring activity. No, the coloring activity main part was there was no coloring activity. There would always be a key or legend. Now, there can only be a coloring activity. Now, in different um, periodic tables that you will see in Google Images or Wikipedia Images, you'll see that they'll have different colors because that's what they used in the key. So if what you're saying is like, let's say that red stands for metals and metalloid stands for blue and non-metal stands for green, then you're going to see that 70% of the periodic table is going to be covered up with metals, and then 10% of that blue, which is the metalloids, those are going to be covered up in blue, meaning it's only 10% and they're metalloids. And then the remaining 20%, that's green. And that's how the periodic table of elements are. That's not what the colors are. Each and everything on the periodic table has a meaning to it. It's just the way of how you look at it. It means how you study the periodic table thoroughly. And that's what the key is. That's why you'll see like keys that, okay, green, metals, yeah, all those. So those are all for today's video. I hope you like how to find. So today we mainly covered on how to find the atomic number and how J.J. Thomson used a cathode ray tube to find the atomic number. We touched on the basics of how or the periodic table of elements, why it's in the tabular form and it's not in just like on a sheet of paper that anybody can use. And then we talked about the color. So these are some main parts about why. So these are the basics of the periodic table. So I hope you love this episode. There's going to be a next episode, and that's going to be on periodic table of elements, and in that we're going to be looking at the elements, and we're going to be remembering or finding out tricks on how to memorize those elements and more, and you'll just have to wait to find out about that video. So I hope you guys love this video. Till then, bye. Thank you, and make sure to like and subscribe.